Bismillahirrahmanirrahim. Assalamu alaikum. I'm from Divisional Public School and Intermediate College, Lahore. Today, our topic is trigonometry. We will discuss trigonometric ratios and identities in this chapter. Trigonometry is a branch of mathematics that studies the relationships between the angles and sides of triangles, particularly right angled triangles. The word trigonometry comes from Greek word trigono and the metron. Trigono means triangle and metron means measures. So we measures the sides of triangle in trigonometry. First we will discuss the given angle in a right angle triangle, which is the base angle in the triangle, and it is indicated by theta. So in a right angle triangle, if base angle is theta, the side opposite to the right angle is called hypotenuse. Here, the right angle having opposite side is h, which is hypotenuse, and the side which is adjacent to the base angle theta is base, and the side opposite to the base angle theta is perpendicular. So, in this reference, sine theta is a ratio of the side opposite to the angle to the hypotenuse, whereas cosine is the ratio of the side adjacent to the angle to the hypotenuse, and tangent is the ratio of the side opposite to the angle to the side adjacent to the angle. So, we will discuss the basic ratios and identities in this topic. Now, if you see here in right angle triangle ABC, base is AB, AC is the hypotenuse, and BC is the perpendicular. Sine theta will be perpendicular over hypotenuse, and that is A over C. Cos theta is base over hypotenuse, that is B over C. And then tan theta is perpendicular over base. You can remember it like saying we have a simple sentence. Some people have curly brown hair through proper brushing. Trigonometric identities. Today we will have the proof of trigonometric identities. Trigonometry is applied in many practical situations. If you see, we use trigonometry in astronomy to calculate distances, surveying and map making, navigations, engineering and physics, calculating heights, to find the height of object like mountains or buildings without directly measuring them. So trigonometric identities are basically very important to learn about. We have three basic trigonometric identities. Today we will discuss their proof as well. First identity is sine square theta plus cos square theta equal to 1. Second identity is 1 plus tan square theta equal to secant square theta. And the third identity is 1 plus cot square theta equal to cosecant square theta. In trigonometric identities, we are going to prove them. Let's see if we have a point with ordinates x and y uh, and the base angle theta in right angle triangle OMP. Side opposite to the right angle is hypotenuse. By Pythagoras theorem, we know that hypotenuse square is equal to perpendicular square plus base square. Here in this triangle OMP, we are having OP as a hypotenuse whose length is R. Hypotenuse square will be equal to perpendicular square plus base square, means r square is equal to x square plus y square regarding this triangle OMP. Now we are going to prove the first identity. If we divide both sides r square equal to x square plus y square with r square both sides, each term will be divided by r square, then you will see that it will become x square over r square plus y square over r square equal to 1. R square will be cancelled with r square. You will find that x over r, which is sine of theta base over hypotenuse, and y over r, which is cos of theta perpendicular over base. Cos square theta plus sine square theta is equal to 1. We got it when we divide by Pythagoras rule to the both sides by this hypotenuse length to the both with each term. So we got cos square theta plus sine square theta is equal to 1. Hence, it is proved that sine square theta perpendicular over hypotenuse cos square theta base over hypotenuse square is equal to 1. So, first identity is proved. Now, the second identity is secant square theta equal to 1 plus tan square theta. As we have by Pythagoras rule, r square is equal to x square plus y square, that is perpendicular square plus base square. Now we will divide to the both sides by x square. If you divide each term by x square will be cancelled with x square, y over x square is equal to r over x square. Now let's see what we do mean by y over x. Y over x indicates tan of theta perpendicular over base, and r over x indicates secant of theta, which is the reciprocal of cos. So 1 plus tan square theta is equal to secant square theta. We get it when we divide the Pythagoras theorem by x square, which is the length of base. Now we can have the third identity. It is proved now 1 plus tan square theta equal to secant square theta. Now the third identity, cosecant square theta is equal to 1 plus cot square theta. How we will get it? We will start from the right beginning. As Pythagoras theorem, we have r square is equal to y square plus x square. R square is actually hypotenuse length, x is the base length, and y is the length of perpendicular in the right angle triangle. So with the reference of base angle, we will divide each side by y square. Each term will be divided by y square. Then we will get x over y whole square. Y square will be cancelled with y square, and r over y. X over y is actually cot of theta, that is base over perpendicular, and r over y is hypotenuse over perpendicular, which indicate cosecant of theta. Cosecant is actually the inverse of sine of theta. So 1 plus cot square theta is equal to cosecant square theta. This is proved by the Pythagoras rule. So what we have learned right now, we have learned that if we divide Pythagoras theorem by Pythagoras rule, all three sides one by one, we will get all three identities. Now look at the some questions for further clarifying our concept of trigonometric ratios and identities. First we have tan x, sin x and secant x. Tan, as we know that tan x is equal to sin x over cos x, and secant x is the converse of cos x. So we will write instead of tan x sine over cos, and instead of secant we will write 1 over cos. Sin x over cos x into sin x into 1 over cos x. Sin square x न्यूमरेटर में हो जाएगा. We will have sin square x in the numerator and cos square x in the denominator. So when we will write in the whole square sin x over cos x, it will be equal to tan square x. So as we have solved sin x, tan x, secant x, as a product gives us tan square x. Now in question number 12 we have cos square theta over sine theta plus sine theta. We have to prove it equal to cosecant of theta. We will take left hand side uh, and we will start that we will take the LCM of both of them. Both values we will take the LCM. Sine theta is the LCM of both values. Cos square theta plus sine square theta. Sine will be multiplied with sine and we will get sine square theta. As we have in the first identity, sine square theta plus cos square theta is equal to 1. Instead of this one, we will apply the identity. 1 over sine theta is actually uh, cosecant of theta. Cosecant theta is the reciprocal of sine. So it is equal to right hand side. By the application of first identity, we got cosecant of theta. Questions. Uh, the next question we have 1 over cos of theta plus 1 over 1 over 1 minus cos of theta plus 1 over 1 plus cos of theta. We will take the LCM in the left hand side as we have done earlier. The product of both values is the LCM. 1 minus cos theta will cancel 1 minus cos theta. We will be left with only 1 plus cos theta, which is going to multiply with 1 in the numerator. In the similar manners, in the denominator, 1 plus cos theta will be cancelled with 1 plus cos theta, and it will be multiplied 1 minus cos theta in the numerator. Opposite sign values, sine theta and cos theta will be cancelled. 1 plus 1 make 2, 2 over 1 minus cos square theta. Uh, if you see the first identity, we have already done sine square theta plus cos square theta equal to 1. We can calculate the value of sine square from here, which will become 1 minus cos square theta. Instead of 1 minus cos square theta, we can write sine square in the denominator. 2 over sine square theta. Reciprocal of sine square is actually cos square theta. So we have 2 cos square theta, which is right hand side. So we have proved that left hand side gives us the same result as that of right hand side. Similarly, in question number 24, in the book, if you see, we will take the left hand side. We will prove that it is equal to secant theta plus 1 over tan theta. We will multiply and divide by secant theta plus 1. Secant theta plus 1 will be multiplied and divided. In the numerator, we will have secant theta plus 1 whole square, and in the denominator we will apply the formula of a square minus b square. Secant square theta minus 1 square, it gives you secant square theta minus 1, obviously, and secant square theta minus 1 is equal to tan square theta. As we have the identity 1 plus tan square theta equal to secant square theta, so we will take 1 to the other side. Instead of secant square theta minus 1, we can write tan square theta, and we will take the square root of both squares. We will first write it as a whole square, and square will be cancelled with the square root, and we will get our right hand side similarly. So we have done our topic of trigonometric identities and ratios. Thank you very much.